In the previous class, I already discussed the S block elements is periodicity in the periodic table, P block elements and D block elements, and how they behave periodically in the periodic table. So today I'll discuss the periodicity of the F block elements. This is the F block elements, and these F block elements, it has the two rows. First row is the lanthanoids, and these 14 elements belongs to the 4 F subshells, and the actinide series, this also has these 14 elements, and this is the part of the 5A subshells. The two rows of the elements at the bottom of the periodic table are called the lanthanoids. Lanthanoids from C, whose atomic number is 58, and for Lu, whose atomic number is 71. And the actinide series starts from the TH, whose atomic number is 90, and it ends with the LR elements, whose atomic number is 103. And these two threes are characterized by the common outer shell electron configuration N-2 F 1 to 14, N-1 D 0 to 1, and NS2. That means the F for this C, this electron is F1, F2, F3, F4, and up to F14. And for actinide is also same thing. Only the principal number, this N, will be different. For actinides, N-2 is equal to 5. That means N-2, 5 means N is equal to 7. That means if you consider the actinoids, then it is the its configuration will be 5F 1 to 14, N-1, that means 6, D 0 to 1, and 7S2. And for lanthanoids, it is the 4F shell. That means 4 means N-2 is equal to 4. That means N is equal to 6. So that means 4F 1 to 14, 5 D 0 to 1, and 6S2. That means every electron, last electron, is enter in this F subshell. It is written there, the last electron added to each element is filled in F orbitals. So these two series of elements are called the inner transition elements or F block elements, and they all are metals. And within each series, that means lanthanoid series or actinoid series, the properties of the elements are quite similar. The chemistry of the early actinoids, that means the elements belongs to actinoid series, is the early. That means first few are more complicated than the corresponding lanthanoids. That means the chemistry of the early lanthanoids is more complicated than the early lanthanoids. And it is due to the large number of oxidation states possible for these actinoids elements. Actinoids elements are radioactive, and many of the actinoid elements have been made only in nanogram level, in Ng level quantities, or even less by nuclear reactions, and their chemistry is not fully studied till now. The elements after uranium are called trans-uranium elements. That means if we see this series, and then if you see that this is the uranium, and after that all NP, PU, AM, CM, BK, CF, ES, FM, MD, NO, LR, all are the trans-uranium elements. So now we'll discuss one small problem. That means in exam it may come that the problem is the elements having atomic number Z is equal to 117 and 120. That means 117 and 120, their atomic numbers, and these are not discovered till now. But from the prediction, we have to place in the group or family of these elements, and also we have to calculate the electronic configuration in each case. That means for elements having atomic number 117, that also you to calculate its electronic configuration, as well as for the atomic number 120 elements, we have to calculate the electronic configuration. So now solution. For the solution, we have to go to next figure. Next figure to see, this is the 117, and this symbol of the elements is TS. So this belong to the group number 17. So if you go back, then it is the halogen family, group number 17 halogen family, and then obviously the electronic configuration. Halogen family means it is the periodicity is 7, and it is the 7s2 7p5, because halogen family's last outer shells configuration will be like that. And before you have to add, these are N, this is the noble gas configuration, and then 5f14, 6d10, all F and D orbitals are fully filled. So in that way, we can write the configuration of atomic numbers 117 elements. And now we'll consider about the elements with atomic number 120. So again, if we see this periodic table, then you see the 118, these elements, symbol is OG. So this is the noble gas configuration, and after that if you put one more electron, then it will come here, that means group number 1, and next electron, that means for the 120, this place will be group number 2. So in this way you to calculate it. So for the elements with atomic number 120 will be placed in the group 2, and group 2 means alkaline earth metals, and it will have the electronic configuration UUO. I discussed in the previous class the meaning of the UUO. This is the inert gas configuration, and 8s2.